Welcome friends to the lecture series on the subject antenna and wave propagation. In continuous to the previous topic, let us begin with the new topic, that is next lecture, that is based on array of two isotropic point sources having equal amplitude. We have already discussed. Now, this case we have visualized unequal amplitude and with any phase differences. So, we can generate what type of radiation pattern it possesses with phase differences, if there is any phase differences. So, let us begin with the content. Here are contents: unequal amplitude with any phases and based numerical problem on this. So, first of all we visualize what is the generic equation of total electric field of two isotropic sources which have unequal phase difference. Earlier we have E 1 and E 2 both are equal to E naught. Now, we have E 1 and E 2 both are different. Okay. So, initially the phase difference we have defined the similar way, beta d cos phi plus delta. Delta is the factor which is any phase difference and beta which is nothing but 2 pi by lambda. Okay. Now, if we draw the vector representation, this is E 1 field, this is E 2 field. Now, the angle between these two is the phase psi and this is the resultant total net electric field over here. Okay. We have showing over here. So, we have to now add these two fields. So, as we earlier discussed, if there is no phase difference at all initial, delta is equal to 0, what happened then? Then these are the similar cases having two point sources with same amplitude and phase, which we have started with first lecture in this antenna array unit. Then second possibility, what if delta is 180 degree, what happened? Opposite phase. This is the second case we have discussed already. Now, so we can begin that delta should be vary between 0 to 180 degree, okay, and both values are inclusive. So, if there is a value between 0 degree, it is greater than 0 degree and lesser than 180 degree, then we have different phase differences, and that is the case we want to discuss over here. Okay. So, the total electric field again E 1 e ki power j psi, E 2 e ki power plus j psi. Okay. Now, here what we have considered, E 1 is lie on the reference plane. So, the total angle difference j ki power 0, which is nothing but 1. So, we have E 1 plus E 2 ki power plus j psi, okay, because the magnitude varying in this direction plus psi, if in this opposite direction it is minus psi. So, that is why we already discussed these cases. Okay. So, E 1 plus E 2 j psi, this is the our net resultant electric field. Now, we can further simplify by this. So, we can take E 1 as a common out. So, what we have 1 plus E 2 divided by E 1 into e ki power j psi. Now, earlier we have E 1 and E 2 both are equal, that is why it cancel out, but not now. This cases we consider some other factor k, and we also consider let E 1 is greater than E 2 or E 2 is greater than E 1, whatever you want to know, whatever you want, consider it. That is why it is a two different phases, sorry, amplitude. Now, moving on further, what we have done, same scenario as we discussed. Now, my total net electric field is nothing but E 1 into 1 plus k into e ki power j psi. Now, this k factor is nothing but E 2 divided by E 1, it is a ratio of amplitude. Okay. Now, what we have to discuss, the total resultant field and the value of phi, same you can see that resultant, simply we know that e ki power j psi is nothing but cos psi plus j sin psi. So, same formula we apply over here and we break this into the net resultant field, which is nothing but E 1 into square root of 1 plus k cos psi square plus 1 plus k sin psi square. And now, what is the angle tan phi? This divide by this factor. So, k sin psi divide by 1 plus k cos phi. So, this way we can define the value of phi over here. Okay. Now, moving on to next topic, that is most important, how to solve the numerical and how to plot the radiation pattern. So, the problem is plot the electric field pattern of array of two isotropic point sources having equal amplitude and spacing is given here lambda by 4 and the phase difference delta value is given over here 90 degree. So, we have given over here d spacing small d, which is lambda by 4 and phase difference delta, which is 90 degree, or we can say pi by 2. Okay. Now, our task over here, first find out the total value of electric field due to the two isotropic point sources, and we have to plot that value. Okay. So, again if you remember two isotropic point sources, the total field E is given by nothing but 2 E naught cos psi by 2. Remember this expression? Now, if we normalize this value, the normalized pattern is nothing but cos psi by 2. Now, the most important role played by here psi, and we know that psi function is defined as beta d cos phi plus delta, because delta is given in the question, which is pi by 2. Now, we need to analyze this value, as we know that beta is nothing but 2 pi by lambda, and in question d lambda by 4 it is given over here. So, what we have to do, just simply put the value and here pi by 2. Now, simplify this, we will get psi is equal to this lambda to lambda cancel out, 2 to 2. Okay. So, pi by 2 plus pi by 2 cos phi, this value we have got over here. Now, in this expression our normalized electric field value is function of cosine and it is value cos psi by 2. Now, here it is psi. So, again you can simplify, psi by 2 is nothing but divide by 2 both side, pi by 4 plus pi by 4 cos phi. So, in order to get our total field, the value of E is nothing but cos pi by 4 plus pi by 4 cos phi. So, this is my field over here, and now what we have to do, we have to plot this value. For different value of phi, we have to plot the value of total electric field, and that is electric field pattern. Okay. So, let us begin with this value. First, let us consider here, draw the table, phi value, here E value. Okay. Let us take phi is equal to 0 degree, the basic thing, we begin with 0, and over here let us draw the pattern. Coordinate system we represent 0 degree, 90 degree, 180 and 270, and over here again 360. Okay. So, when you put phi is equal to 0, what we value get, cos 0 is nothing but 1. So, pi by 4 into plus pi by 4 how much, pi by 2, and cosine pi by 2 as we know that this is 0. So, our first term value is nothing but 0. So, we are here in this curve, in this coordinate system 0. Next value we will take, let us take 90 degree. So, again when you are going to solve, cos pi by 2 cos 90 is nothing but 0. So, this term is going to be eliminate. So, cos pi by 4, if you remember the value of cos pi by 4 is 1 by root 2. So, write down over here 1 by root 2. Later we plot the curve, first we find out the value. Okay. Next, moving on to the coordinate system, let us plot one another value in between this two, let us say 150 degree, or you can take 120, 150, whatever you want, it is sample data we are processing over. So, let us take 120 degree. So, the value of when you solve this, it is close to point something 94, you do the calculation part from the calculator, it is basic formula cos 120. Okay. Now, moving on, next value 150 let us take. So, it is again close to 0.99, and at 180 degree our value, when you put 180 degree, this value is nothing but maximum value, which is 1. Okay. So, we have evaluated the maximum possibility of phi angle for different value, we have to different value of electric field. Now, we have to plot this value. So, let me change this color of this pen, let us take green color. Okay. So, first point at 0 degree, what is the value? 0. So, over here, okay, we have the value over here. Okay. Next value, 90 degree, and what is value? 1 by root 2. 1 by root 2 is nothing but 0.707. So, somewhere over here our point. Okay. 180 we have maximum value 1. Okay. In between what we have value? 120. So, this is 30, this is 60 degree, this is 120, this is 150. Okay. Now, what is the value of 120 degree? 0.94, close to 1. Okay, somewhere over here. Again 150, 0.99, somewhere over here. If you go further on, it is always the same value which is upper coordinate to the lower coordinate. That is why perfect symmetry, in order to form perfect symmetry. So, what we have to do? Just match it up. So, if you draw or calculate the value of 30 degree, you find out it is close to 0.1 or 0.15. Okay. So, you can do the calculation part. I am plotting over here directly. So, at 0 degree I have 0 value. So, it will go like this. Sorry. Okay. It will go like this. Start from here and goes on increasing, maximum at 180 degree, and same pattern you have to follow over downward. So, this is the radiation plot or electric field plot of this function cos pi by 4 plus pi by 4 cos phi. Okay. Again, how we solve this? First, what is the expression of total electric field for 2 point sources? We already calculated previous cases. So, cos psi by 2, the normalized value cos psi by 2. Then the psi function, which is beta d cos phi plus delta, because in question there is a phase difference of 90 degree. So, simply on solving we will get our final expression, this value. For different value of phi, the value of electric field is going to be changed, because this is the only variable over here. So, for different value of phi we have calculated the magnitude, the value of electric field, and again we have plotted over here. So, this is the rough representation of electric field plot for this function of two isotropic point sources having phase difference of 90 degree. So, let me give you the correct one this way, the same way. Okay. You can find out these are the 2 point sources separated by lambda by 4, and these are the value, these are the net electric field. Okay. So, moving on to the next question. What happen if I decrease or increase the spacing value? Now, in next question the only change I have done, d is equal to lambda by 2. Okay. So, what is the value of net electric field? Again remember, cos psi by 2. Now, what is psi? Psi is equal to beta d cos phi plus pi by 2, 90 degree. Okay. Now, what is beta? 2 pi by lambda into d, spacing is now lambda by 2, cos phi plus pi by 2. If you are going to solve this, the value we will get, I am directly writing this, psi by 2 is nothing but this value pi by 4, this lambda to lambda 2 to 2 cancel out, what we have? Pi by 2 cos phi. Okay. So, our final value of expression of electric field is cos pi by 4 plus pi by 2 cos phi. Okay. Can you see the changes? What happen if I increase or decrease? Here what we have? We have increases the spacing between the two element. Earlier it is lambda by 4, now it is lambda by 2. So, what happened? The value of pi by 4 plus pi by 2 cos phi. Now, you need to find out, or we have to find out what is the plot of this value, which is cos pi by 4 plus pi by 2 cos phi. Same procedure we have to adopt. For different value of phi, we need to find out the value of electric field, and that's value we need going to be plot over here. So, moving to the next, let again same the process, phi value I have to calculate electric value for different phi value. So, our function, if you remember, it is E is equal to cos pi by 4 plus pi by 2 cos phi. So, first value let us take 0 degree, again cos 0, maximum value 1. So, pi by 4 plus pi by 2, 3 pi by 4, again that is nothing but 1 by root 2 value if you are going to solve this. So, we will get 1 by root 2. Earlier at 0 degree we have 0 value, now we have getting value 0.707. Okay. There is a change in the pattern obviously. So, let me draw the coordinate system. This is 0 degree, this is 90 degree, 180 and 270 and here 360. Okay. Next value you will take, let us take 60 degree. Okay. When you are going to solve this, cos 60 and then total value of this cosine function, we will get the value of final, I am giving you the expression, it is 0. You do the calculation part. Okay. So, next value you will take 90 degree, again 90 it is going to be 0, again pi by 4. So, 45 is nothing but 1 by root 2 and so on, you can plot it. Next 120, 150, 180, same interval we have plot. So, I will give you the expression of 120 degree. 120 the value is 1 and at 180 degree the value is 1 by root 2. Let me write over here. Okay. So, it is maximum at 120 degree. So, here the 30 degree line, here 60 degree line, 120, 150 and this is again 180. So, let me change the color of pen, let me take red color. So, we can easily understand the plot variation. Okay. So, earlier at 0 value we have 0 value, but now we have some value over here which is 0.707, okay, less than 1, and we have maximum value at this value 1 over here 120 degree from this calculation. 180 we have value, this value 1 by root 2, 90 degree again 1 by root 2, again when you are going to 270 it is again 1 by root 2, same value. Okay. So, if you are going to plot this, what we have, value is only 0 at 60 degree. So, this is the 60 degree line. Okay. So, some over here the curve is look like this and over here it is going to be increased and going to be like this. So, this is the effective pattern of this function cos pi by 4 plus pi by 2 cos phi. Have you seen the changes between the pattern? Earlier what we have, there is no back lobe. If you consider this is the main lobe major system or main lobe where the signal strength is maximum. So, you can easily find that this is the value, but here some signal strength also available. So, we can say that minor lobe. Okay. So, there is a change, earlier we are not getting any type of back lobe. If you remember the figure, see it is very less amount, there is some side lobe there, but back lobe is not there, but now there is, and this is the effective representation. Okay. Same way we have done this. So, it is very from the conclusive point, if there is existence of phase differences which may govern the existence of or possibility of side lobe and back lobe there, because as a RF engineer we never want that our main signal strength is always in forward direction or in direction toward the receiver side where we want to communicate the signal or send it toward. But it also shown from here, there are always existence of some minor and back lobe. We cannot minimize it to 0 value, but we can take the minimum value as possible as. Okay. So, there is a different technology like pattern synthesis we have to do. Okay. So, in order to eliminate this type of figure, because we always want to focus signal strength in a specific direction, we never want back lobe to be present in a signal or sorry in an antenna basically. Okay. So, this way we have plot the radiation pattern or electric field pattern of two different value of spacing, d is equal to lambda by 4, d is equal to lambda by 2, and you can change on d is equal to lambda and you see the what is the effect. Okay. So, this is it about this lecture. Thank you.